All right, let's go to number 6. You know what? Somebody just recently asked me, how do we do this? How do we attack this? And I said, you know what? Let me make a video just for you. So when we look at this problem, one of the first things we notice is that we got a bunch of stuff going on. But it's not a bunch of crazy stuff. Again, you don't have radicals, you don't have fractions or any weird stuff going on, you just have a polynomial. And in a polynomial, especially when you have multiple instances of the variable, you might think to factor. Well, when you've got 4 terms, the first thing that comes to my mind is to factor by grouping. That doesn't mean that you can factor by grouping, but that is something that we should try. So let's see what happens. So if I take this first group and I try to factor by grouping, the common factor here is x squared, and then I'll be left with 3x plus 2. In the second group, which begins with subtraction, I've got to factor out the negative along with the common factor for 21 and 14, which is 7. And that leaves me with positive 3x plus 2. And now, since these guys are exactly the same, it tells me that factoring by grouping was a fantastic idea. Hey, Mathman 1024, are you always that good at factoring by grouping and you know it's going to work? Well, Jimmy, yes. And so now that I've got this factor and it equals 0, this is a prime example of using the zero factor theorem. So you take each factor and you set it equal to 0 and you solve it. So 3x plus 2 is equal to 0. Or you take the other factor, x squared minus 7 is equal to 0. You don't have to do these at the same time. You can just kind of block one off and focus on the other. So don't worry about this guy, just kind of block him off and focus on the linear factor, 3x plus 2. Solving this guy for x, you just need to subtract 2 and then divide by 3. If you want to show each step, you can. I think we've done enough of these that you can see to just move the 2 over and divide by 3. Over here, I see that I've got x squared, so it's a little bit different. It's quadratic, but it's a smaller quadratic equation. So since this is the only thing that is connected to the x, the square, get this guy by itself by moving the 7 to the right side. And now, to undo the square, we take the square root of both sides using that square root property. That gives us x is equal to plus or minus the square root of 7. If you look at the original problem, since this is a polynomial equation, the degree here tells me how many solutions I'm supposed to have. This is a 3, so I've got 1. The plus or minus gives me 2 more, so altogether I have 3 solutions.